Hey, how are you? So this is going to be another miscellaneous sort of project, and right now what I'm trying to do is just solve a simple problem that I have, and I'm just going to show you kind of the steps I take to go through it. So what I've got here is my problem is my oscilloscope. The oscilloscope itself, this piece of equipment, this happens to be a BK Precision Model 1431. The oscilloscope seems to be okay, as best I can determine, but I'm getting some trouble with the readings. And I think the trouble is with this particular probe. An oscilloscope probe, in this case, it's going to plug in with the connector here, and then you connect up the circuit you're trying to test with the ground lead and this probe. Let me give you a close-up of, so here's an extreme close-up of the probe, okay? Now you can see there's a little thing you pull down, and you hook this around the particular wire that you want to connect to, and then you release it. It's supposed to grab onto that. But you'll notice here this has been kind of taped up. I'm not sure what's going on here because I inherited this oscilloscope. Down here, the ground clip is a little goofy. It actually broke off right here, and I had to resolder that. That's not a very good job. I'm not proud of it at all. The clip is twirls around. It feels like it shouldn't really be doing that easily. I'm just not sure about it at all. And I'm getting some kind of goofy readings on it. So instead, what I'm going to do is I'm going to just create a new set of oscilloscope test leads here. And we're just going to see how that compares this old one with the new set that I'm going to compare. Okay, so that's the project. So there are a couple of ways we could go at this. I could just take the bits and pieces of this old probe that I have and try to make use of them. For example, this particular coax connector is useful, but I'm not going to try that. I'm going to save this for comparison purposes. So we'll put that to the side. And instead, I'm going to use another sort of thing. I'm going to use a combination of what I've got. This is what I have, and electrically it should be just fine. I've got just a bundle of coax wire, very thin coax wire. The inductance is 50 ohms, as is typical for this kind of cable. I have a connector here, which on one end is the sort of standard, what I think of as standard coax connector on one end, and on the other end is a PNC connector. I just happen to have a gob of BNC connectors. A friend gave this to me. This is what happens. When you get into the hobby, electronics, you just pick up bunches of pieces. So I mean, look at all this, is just all this, more than I will ever use, but I've got them. This is what I have. So you use what you've got, and if it's electrically going to be okay, then you just go with that. All right? So that's what I've got. I've also got a couple of old clips here that I really have no use for. I realize that these will be excellent pirate. I'm just going to take these and make use of them. This particular clip is kind of odd. I'm just going to clip this off and use it for the ground, and then this one kind of has a very pinkish red tint to it, so that'll be the signal, and we're just going to use what we've got. And in the meantime, I'm going to show you a couple of things about how to work with coax, and we'll talk about shrink wrap or shrink tubing. Okay, so let's go forward. All right, so I thought I'd show you the difference here that we're looking at. This is a PL259 type coax connector, and what they've done here is they've created it. They've made this the male end. We won't get into that, why the naming convention. And then here is a female end. Over here we have another BNC, which would be connected to the coax on this side. The BNC will come into here and connect up. The BNC connectors tend to be used in laboratory equipment. I'm not quite sure why the oscilloscope, way back there, is equipped with the PL259 connector, but it is, and so we'll work with what we've got, and just to let you know, these are the two connectors that we're working with. So the first step will be in cutting our new cable to length. Here's the new cable that I've got. Here's the old cable. The old cable just stretches out, about so far. And so I'm just going to match that up. Kind of hold this roughly. It doesn't have to be, there's nothing magical about the distance. It's just what is good. It looks like the cable probably extends up, since we're going to go this far up to the probe end, it'll be about there. I'll put that down and then snip away. Boom. So this will be the cable that we use. This is now access for the next project. And so then what we're going to do is now strip off the insulation for the end here. Okay, that's what's next. Now it's time to strip off the insulation. You'll notice here I have here a pair of actually very cheap wire strippers. I need to be very careful with these because they're not very good, so I have to be more careful than I normally would. What you do is you look for the diameter of the wire that you're trying to strip. You'll notice here it looks about like that, and you adjust the little wheel here to get the right diameter. And that's about what I'm looking for right here. So what I'm going to do is just gently press on the cable to indent the insulation. That's all I'm doing here. I'm just trying to indent the insulation, and I'm doing that very gently. And you can see there's a dimple that's beginning to form. I just keep doing that, and then I might start kind of tearing at the insulation this way. Now I'm doing this particular technique in this way because these wire strippers aren't very good, okay? So now that I have that, I have a good mark as to where I want to go. The next step is actually, again, this is kind of awkward because of the nature of these strippers, but this is what I'm doing. Now we're going to take a utility knife very carefully. Just kind of press into the insulation. And you'll notice that just by pressing in, I have cut the insulation. And just by pulling on it, I'm separating it. Now the trick is to then just pull off the insulation, and now I'm left with clean braid underneath. That what we have here is wire braid, and this provides the shielding for the inner wire right here. And that inner wire, surrounded by the outer wire, defines what is coaxial. And if you wanted to get into the whole Greek or Latin or whatever it is, you notice it's coaxial to centers. And so there's one center, and then this is surrounding the same center. They kind of share the same center. And here, what this piece wants me to do is to actually clear off enough of this insulation so that the end of the inner wire, that's that one that you can barely see, will stick out of that little hole right there. And so what we have to do is kind of look at the length and get it down, get the braid actually down just a little bit further, and I'll show you why that's the case. So again, take this, we just kind of indent it to kind of give it a little bit of a mark, weaken the insulation just a little bit, enough to be able to come again with the utility knife very carefully, because I don't want to press too hard, because I don't want to cut any of that braid, and of course I don't want to cut myself. All right, we separate it. Okay, now if you had a good pair of coax strippers, you wouldn't have to go through all that nonsense. I don't have that luxury with me, so I'm using what I've got. All right, now that we've done this, here's the next step. All right, now that we have the braid exposed as much as we want, here's what's going to happen. We are going to now push this braid down. Notice it now slides. And what we're trying to do is actually get the braid to fold in on itself. Okay, now I'm going to work that off camera. It isn't very pretty, but that's the idea. I'm just working the braid down, back around the outside insulation. And then what I want to do is I want to strip off this part of this inner insulation. So again, with my bad pair of wire strippers, I just kind of dimple it in, okay, and I kind of, this is awkward for me, but then we just kind of start moving it back and forth, seeing if we can get that thing to separate out. And here we have the final stripped product. Notice we have a bunch of strands here as well. So I'm going to, again, do the same thing. I'm going to twist those so that it creates a more, I don't know, it's just more workable this way. Let's twist it all the way up. Okay, there we are. Now what's going to happen here, this is where the trick comes in. So we look at this and we feed this in, and hopefully the little strands will fit in through that little teeny hole down there. Okay, that's the idea. And it may not fit, so we'll see if we can just kind of tighten this up and see if we can get this to go. Yeah, it's just a little bit too thick to get into that little hole. So what we're going to do is back it off, untwist, and we're going to snip off a couple of those strands to thin it out a little bit. Okay. Twist them up again. Sorry, get that back on camera. Again, I'm sure that if you're a lab worker, you're probably screaming, oh, don't you know there's a special XYZ technique? And the answer is no, I don't. I'm just doing what I can do. Again, feed that through, and it's just all right, folks, so I've actually got it in, and now just gently pressing it in, trying not to crush anything, and then you'll see here that what I'm going to do to kind of help it go in is I'm going to now screw this outer nut over the braided insulation. That's actually how that's supposed to work. And then at the same time, that's gently forcing that other strands up into the barrel. That's what we're going to do. And I'm going to kind of help it by sort of pressing in. Okay, it is not pretty, but it is connected. Now here's how I can tell. So I've stripped off the other end of that cable, and I'm bringing out my little volt ohm meter, and I'm going to just check to see if there is electricity that's going through, and the answer is yes. Looks very good on the outside. So this outside bit is connected here electrically. Now what I'm going to do is connect up that inner prong with the inner bit here and look for the meter, and there goes the meter. So we've got a good connection. Now it's just a matter of cleaning up this. Ugh, it's a mess. So I'll clean that up and come back to you. Okay, so I cleaned it up a little bit, but it still looks pretty ratty there, right? I don't like that. But we're going to kind of fix that. We're going to fix that with, this is very sloppy. I'm not recommending, this is going to be screams of howls of protest from other people, but I'm going to fix this up with electrical tape. The reason why I'm going to do that is because I'm going to show you how to use electrical tape. Most people don't actually know how it works. So let me give you a little lesson. This is electrical tape. Now, it's not merely just black tape. It actually has a characteristic which is very important for what we're going to be doing. It stretches. And this is how it works. So if I go take my piece here, and I get my little tape started, now most people just put on the tape and they just start wrapping it. But that is not how electrical tape works. It's not just a wrap it around, it's a stretch. You see how it gets tight there? That's what you do. Stretch, and then it tightens over itself. It takes a little bit of strength to do this. It tightens over itself, and it creates a weatherproof bond. And it's very, when it's done right and such, then it comes out being very effective And then you, come on. And now we've got something that as time goes on, it will begin to, if I've done this right, which I really haven't because it's been awkward to try and do that, but it will start contracting on itself to create a very, very tight bond. And of course, it will prevent any sort of electrical sort of leak from the little pieces of braid that are underneath there now. All right, so again, not my proudest moment, but it works, okay? So that's the one end. Here's where we are. Here's the original connector that I'm going to use as my basis. I'm just gonna plug that right in here, and it spins on. Now I have this connector, and it will just fit in right like so. And it will kind of slide in and turn and lock. And now I've got a good end into the oscilloscope. Now what we've got to do is work this end. All right, so now what I want to do is I want to create a couple of wires, a couple of leads that I can then attach these clips to, and it will make a useful oscilloscope test lead. So what we're going to do is pretty much exactly what we did before, except we're going to make a very, very long wire. All right, so what we're going to do is we're going to cut off the insulation, probably down here, and we're going to make a big, long wire out of the braid. Let me show you how we do that. Okay, so now I've made my cut, and I'm now going to just pull this off. By the way, the trick I used with the electrical tape, I may not be able to pull straight off here. I'll have to maybe cut in sections here. The trick I use with the electrical tape, it's the difference between what's called just plain black tape and what's called friction tape. Friction tape is really what we're looking for. That's the stuff, if I've got my terminology right, that's the stuff that stretches and then contracts on itself. So just plain old black tape, a black tape is not going to really do what you really want it to do here. You really want the actual, in this case, it's a 3M Scotch 33 plus, okay, tape that they've manufactured. That's the 3M brand. All right, so now I tried to cut this and I can't really pull it off. Oh, that's just too much. So what I'm going to do is I'm going to do it in stages. I'm going to cut here and then pull them off one at a time. So here's the first section off. Everybody's saying, Eric, you just ought to get yourself a new pair of wire strippers. That is true. But I'm doing what I have with what I've got. And yes, I should go down to the hardware store and buy a high quality pair of wire strippers. That's not happening today because I want to get this done. So we're going to be very, very careful and work with what we have. That second section now off, and now the third section should slip off with a minimum of fuss given, there we go. So now we're done. So now we have this very nice long length of braid here, okay? Now what are we going to do with it? Stay tuned. By the way, every time I cut the camera, I'm putting away things I no longer need. I feel it's very important to keep a clean and clutter-free workspace if at all possible. As a matter of fact, these dorky little wire cutters, these need to be put away. Excuse me while I do that. All that obsessiveness or whatever, but I feel that that's important. Bad things happen in the midst of clutter. All right, so what I'm going to do here is I'm going to take this braid, I'm going to hold it, I'm going to press in on it. I want you to watch this. And notice how it presses in and how it kind of expands out here. That's what I'm looking for. All right, so what I want to do there is take my owl. This happens to be a soldering owl that I got, decades ago. What I'm going to do is start picking at it a little bit. Just going to start expanding out this little section and uncovering the insulation underneath, okay? I'm going to expand this out even more, try to uncover more and more of that insulation. We're going to just stretch it out and work it, okay? I'm going to go off camera. Okay, so now I've bent this down and you'll begin to see the interior insulation is now showing. Okay, so we're just kind of working that gently, trying not to break any of those braids. I mean, inevitably, some of them do break, but we want to try and avoid that as much as possible. Okay, so we want to pull that down, keep working it gently. And then eventually we're going to be able to put our all the way through, like so. Now we're getting close. Now what I want to do, pull this, and I want to pull that center insulation through. See what I'm doing there? Pulling it through. Pull it all the way through. Voila. Now we have a free piece of, now we have two wires. We have this braid, and then we have this center conductor. So now I'm going to just kind of pull gently, just kind of get that shape back in there, right? And now I'm going to actually, I have a purpose for doing this. I'm going to pull this now nice and tight, and it's a little frayed over here. So I'm just going to, I don't know, just spin it like I like to do, twisting the end of the wires. Now I have two wires. These are going to be my two leads. And so you might be thinking to yourself, hey, so that's great. So I see where he's going. He's going to kind of cut off the insulation here, and he's going to attach the clip here. Exactly right. That's exactly what I'm going to do. But then this is going to be a ground clip, and that's fine. But then we're going to have all of this insulation here, all of this uninsulated braid here, and that's what I was thinking about. Well, hold on. How am I going to insulate that? Well, I could wrap it in tape. No, that's a very, very bad idea. Very clumsy, very awkward, not going to work. Or I can use some modern technology. It's all of about 50 years old. Let me show it to you. You may have heard of shrink wrap. This is heat shrink tubing. And what we do is we get a piece of heat shrink tubing, and we put it over the wire that we're wanting to insulate, and then we will later heat it up and it will shrink over that wire. Okay, so here's a section of that heat shrink tubing. And to make it work, it's going to be about so long, but we need some room here to do all of our work. So we're going to kind of cut it about like so, and then cut here, and then we'll be about right. So now the trick will be to get this piece of heat shrink tubing over this braid. So one of the ways I'm going to do that is, again, every time you want to thin out kind of wires, you kind of pull and twist, and that will help a little bit get the shape that you're looking for. So I'm going to get this heat shrink tubing on very carefully by just bringing it down, and it's now thin enough so that it fits. And where it isn't, I'm just going to kind of give it a little bit of a twist to help it kind of fit in a little bit. Just feed it through. It's going to be tight. That's the idea. All right, after a lot of coaxing, we finally have the heat shrink pretty close to the end here. And now we're ready to get these ready for their new connectors. I've stripped off the insulation off of this wire, and again, I'm going to spin and twist it to give it a little bit of form. Okay. So that's been twisted. We're going to do the same thing here just to kind of neaten it up. And now we're ready to make our connection. All right, so you see I have a soldering iron here ready to go. It's warming up, and we have some solder. We have the leads kind of immobilized in this little mini vise. And all I'm going to try and do is just what's called tin the leads, which is to put some solder in them. Just melt enough solder to kind of get them into kind of a solid piece of metal. That's the idea. And then when they're in that solid piece of metal, they're just a little bit easier to work with. They kind of, things are a little bit more predictable. All right. Now, another thing to just mention is that you'll see here that, you know, I'm going to be handling solder, and already my fingers, you can tell, are just a little bit discolored. Always a good idea to wash your hands after you're working, because you're touching a lot of things with a lot of potentially difficult chemicals. Some people are more sensitive to lead than others, and there is lead in solder. So let's try to be safe. Wash at least, come on, wash your hands after you are done working on electronics, okay? Oh, notice here how it looks pretty good, but you notice how the end is beginning to discolor. There's kind of a, if you can see it, sort of an orange, kind of a yellowish glow to it. And, or not glow, but I mean a discoloration. And the more I'm holding it out here, it's getting darker and ickier. So that's why we have this little sponge here that is soaked with some water. And what we do is we just kind of tap it and we look at it now, and look at it, it's all bright and silvery, and that's what we like. So, and granted, the water cools down the tip just a little bit, but not that much. So then what we're going to do is we're going to just test it, make sure the iron is hot. Clearly it is. And one of the techniques to soldering is rather than just taking the hot iron and just pressing it up against the metal, we're actually going to put a glob of solder on it to give it a little bit of kind of a liquid sort of contact with the metal. So I'm going to dress it up a little again. We see that there's a little bit of glob there, and then we kind of press that on. That makes just a better heat connection with the wire. And then you'll notice here, I put the solder in on the other side of the wire, and the solder just begins to flow. And there we are, we're done. We're done with that one. Same thing over here. Kind of freshen up the tip. Oh, sorry, give it a little glob. Touch it. And the solder should just begin to flow. There we go. Very nice. And there we have a fairly well tinned couple of leads. Now we're done with that part. I don't know if you've noticed here, but look at the black part. Notice how the black shrink wrap has begun to take on the form. That's because it's now hot. All right, so this is the lead that I was going to use and kind of pirate it. By pirate, that means taking it out of one use and giving it into another use. So I was going to use this, and it presents a problem because the wire is pressed fit into this lead. It's not a very high quality lead, but it's going to be good enough for what I want to use it for. So what I'm going to have to do is kind of to get the wire out, I'm going to have to, again, work it, and I'm going to be, prying it open and stuff like that. So I'm going to do that, again, off camera so that you don't see all the ugly bits. All right, well, that wasn't as bad as I thought. I was a moment concerned that there might be, non-family friendly language being used, but actually this came apart pretty well. So that'll be the basis for my ground clip. This is now either tossed, or maybe we could make use of it in some other project down the road. So we're going to just put this to one side. Boom, done. And now we're going to solder the braid part to this piece right here. All right, this is going to be a tricky part. I'm not sure how this is going to turn out, but I'm going to attempt to tin, that is to place some solder on this clip so that it connects easier to the clip. So let's see if we can heat this. Okay. And put our solder over here. Yes, it is melting. Good. All right, so we just remove that. That's actually a really, really good sign. I'm real pleased by that. The next step is to connect the ground strap lead into this clip mechanically. By that I mean we're just going to put it in and then press down the little things there and make a good mechanical fit. All right, so we've gotten the soldered bit into the clip, and now we're just going to press down on it real hard mechanically so that we have a decent mechanical fit. It's not going to go anywhere, and it actually is probably good enough right now that it would be good enough for our electrical purposes, but we're not going to let it lie like that. No. So what we're going to do is we're going to get this anchored up, and we are going to again make sure that the that there's a good electrical connection all the way through here. So again, we start seeing the solder flow. We're just going to put a bunch of solder in there. Yeah, there it goes. Okay. All right, let's sit there for a little bit. Cool off. And now we've got a good electrical connection right there. And that takes care of our ground strap. Now for our signal strap, we have this old, kind of beat up, faded, red colored, now it's more pink strap. And you'll see here, this is going to work a little bit different. What we're going to do is we're going to feed the wire in through here. It's going to come up through this little notch, and then we're going to kind of mechanically connect it to the screw. All right. And so that's the next step, and that's what I'm going to do off camera, show you when I'm done. Okay, so that's what I've done. I've fed this all the way through. Now we're going to use this little hook. There we go. We've got a good, now, mechanical connection. All right? So just tighten that up, kind of hand tight. I'm going to pull this down. Oh, that's interesting. I don't know what that is. Yuck. All right, and now what we're going to do is we're going to put a little glob of solder right in there. Okay, getting ourselves ready. Kind of do a little bit of that, get a little heat conduction. Okay, now with a little bit of finagling, you can see that we actually did get a nice solder joint right in here. Okay, and so now we actually have our test lead. Okay, so I think we're done. Now the ultimate test is to see if we have continuity. So we're going to go from outside to outside, in this case, right here, and here, and we're going to test. There we go, good. That looks great. Same for the inside. Remember, the inside is just this little gold part right there. And that looks very good. All right, looks like we've got a good test lead. Much more robust than what I had before. So we can test this now by plugging it into the oscilloscope. There's the test lead going on. Turning on the scope. And then I'm going to do, to test it, will be kind of fun. This is just one of the fun, funky things that you learn. So as the scope warms up, you can see it's picking up a little bit of just stuff that's coming in from around me, just a 60 cycle hum. So if I actually touch it, notice that human beings make great antennas for 60 cycles. So there you go. And then you can tell I can just ground it out. It comes out 0. And yeah, this is nice. This is perfectly adequate for a direct, unattenuated probe. So that's really cool. Hey, this worked. What do you know? All right. So proof of the pudding is in the eating, and we have had our dessert. Well, I hope you enjoyed that little small minor project. Again, all we're trying to do is just to solve a simple problem using some simple techniques, things that you would want to know as you're working on electronics, how to solder, how to strip wires, how to use what you've got, just a little bit of resourcefulness. And so I hope you enjoyed this. And if you do, please, of course, give it a like down below, and hope that you stick around to see what goes on next time. Bye-bye.